Hi, and welcome to another flipped video lesson. Tonight's lesson for Algebra 2 is on graphing exponential functions. Pretty much the basics. We'll be covering how to graph, what changing the base means, what the function looks like in a general format, and how do we change the y-intercept of the graph. We'll also be covering some vocabulary like asymptote, remembering and recalling that the asymptote of a function is a line that a graph gets increasingly close to but never touches. Okay, so we're going to start with a very basic function, y equals b to the x. So every exponential function is of the form y equals b to the x. An exponential function must contain a variable x in the exponent in order for it to be exponential. So the base is going to be any number defined greater than 0 and a b that does not equal 1. And I want to just discuss this for a second. So why can't we have a base equal to 0? So it's pretty self-explanatory. If we use a 0 as a base, 0 to any power is always going to equal 0. And we're just going to have a horizontal line, so we're not actually going to do anything that looks like an exponential function with a horizontal line. And b cannot equal 1 because if b equaled 1, then 1 raised to any power is always going to equal 1. And that again is going to be a horizontal line and not an exponential function. So in the function notation, f at x, b is raised to the x power, where b is greater than 0 and not equal to 1. Okay, so I'm going to start off with a f at x equaling 3 to the x power. Okay, so this function, 3 to the x power, I'm going to just write a quick xy chart for the values. We start with some negatives. Let's put in -2, -1, 0, 1, and 2. If we evaluate the exponential function at each one of these x values, 3 to the -2, recalling a negative exponent, will reciprocate the base and raise it to a positive exponent. So 1 over 3 squared is 1 over 9. 3 to the -1 power is 1 over 3 to the first power, or 1/3. 3 to the 0 power, anything to the 0 power equals 1. 3 to the first is 3, and 3 squared is 9. If I were to graph the function on the xy coordinate plane, I always graph my y-intercept first. When x is 0, y equals 1. The function then goes over 1 and up 3 units, and then over 2 and up 4, 5, 6, 7, 8, 9, maybe way up here, 9 units, comes down like that. To the left, at -1, it's going to equal 1/3. Then it's at -2, it's going to get even smaller at 1/9. And then you can see the pattern. If I get smaller x values to the left, -3 is going to be 1/27, and smaller and smaller and smaller until it approaches y equals 0, but it will never become y equals 0. So let's talk about that for a minute. Is there any value for x that will ever give me 0 for an answer? Well, the answer is no. There's nothing that I could possibly put in for that exponent that's going to give me a value of 0 after I take that base of 3 and raise it to some exponent. There's nothing. The smaller and smaller I get, increasingly smaller, if I have -1000 as my exponent, it's going to be so tiny and so close to 0, but not quite 0. So in this case, the x-axis, which has the equation y equals 0, is the asymptote of the function. Okay, write down anything that you have a question on as I take a moment to erase. Next, I'm going to show you a graph of a fractional base. So all I've said that the bases could not be 0 and cannot be 1. So the base has to be greater than 0, and the base cannot equal 1. What if I have a base that's between 0 and 1? In other words, I want a base that's a fraction. So let's do f of x equals 1/3 to the x power. Okay, this is a fractional base. 1/3 is between 0 and 1. And now I'm going to take that base and let's see what happens. Okay, so an XY chart is going to really show me what's going on here. I'm going to use the same x values, -2 to 2, and we're going to evaluate 1/3 to each of these x values. So 1/3 to the -2. A negative power reciprocates the base, so it becomes 3, and we raise it to the +2, which will be 9. 1/3 to the -1, reciprocate the base, upside down, 3/1, raise it to the first power, that'll equal 3. Anything to the 0 power is 1, 1/3 to the first is a third, 1/3 to the second is a 1/9, and if we continue that pattern, you can see it's going to get smaller and smaller and smaller, approaching 0, but never equaling 0. So the graph of this function, again, for exponential functions, it's always a good habit to graph the y-intercept first, 0, 1. I usually graph my integer numbers next. At -1, I'm up at 3. And at -2, 4, 5, 6, 7, 8, 9, I'm up here. Come down. And on the right side this time, I go up a third at x equals 1, and when x equals 2, I'm at 1/9. And I'm going to get increasingly close to the x-axis without touching it. And again, y equals 0, or the x-axis is my asymptote. Now in the first example, it was small values on the left and increasing to the right, which was an exponential growth function. In this case, our base between 0 and 1 signifies that it will be an exponential decay function. So the difference between the two is the base that's bigger than 1 will make growth, and the base that's between 0 and 1 will give me decay. Okay? Those are the essential basics. Now let's talk about the domain and range of the function. For both functions, the first one as well as the second one, our domain values are any values of x. Because as you can see, I can go infinitely to the right and infinitely to the left. So my domain is the set where x is all real numbers. All real numbers, okay? X can be any real number. But the range, however, has a restriction. It's the set of the y values, but what do the y values have to be? In this case, they have to be greater than 0. It will always be stated as above the asymptote. So whatever the asymptote is, again, the line that the graph gets increasingly close to and never touches, the y values, the range, will be all the values above that. Okay, but we can mess around a little bit with our asymptotes. We can change them. So we're going to talk now about how we get that to change and what we need to do to shift a graph. Okay, so just as I'm erasing, think for a moment. If there's any questions that you want to ask in class, jot them down. Or if you're not in my class, you can jot them in the comments, and then I will answer you. Okay, so changing the y-intercept. All right, now, with any function, if I want to shift a graph up or down, what have I always done? I've always added a constant at the end or subtracted a constant at the end. Think of the quadratic function. If I have y equals x squared and I want to shift it up, I take y equals x squared and add 5. That moves everything 5 units up. If I want to shift it down, x squared minus 3, and that moves it 3 units down. Well, exponential functions are just functions like anyone else, and all we're going to do is add and subtract, and we're going to shift them. So for the first shift, I'm going to take the same function, 3 to the x, and I'm just going to add 2 at the end. So now every function is going to change by 2 units up. So let's watch what happens. I'm going to use the same values, plug them in. 3 to the negative 2 is 1 over 3 squared, and 1 over 3 squared is 1/9. But then when I add 2, it's 2 and 1/9. 2 plus 1/9. 3 to the negative 1 is 1 over 3. Add 2, and I get 2 1/3. At 3 to the 0, I'm at 1, and 1 plus 2 is going to give me 3. So my y-intercept changed. At 3 to the first power, I get 3 plus 2 more gives me 5. And 3 squared is 9. Add 2 to 9, and we get 11. Okay, so recalling the asymptote with the first function, which is y equals 0, but now I've shifted everything up. And if I think about this, as I get increasingly further away from 0 on my negative end, so if I get smaller and smaller, I'm going to always be adding 2 at the end, but I'll never actually equal 2. So my asymptote shifts up y equals 2. Asymptote. Okay. So the first thing I should do in this case is go up to y equals 2 and draw a line and label it y equals 2, knowing that my graph's range of my function has to be all the y values greater than 2 for the range. Okay? Now, the first point I'm going to graph again is 0, 3, which is my y-intercept. I'm going to go 1 and count up 5. 1, 2, 3, 4, 5. I'm going to go over to x equals 2 and graph 11. 6, 7, 8, 9, 10, 11. And the function will pretty much look the same, except every point just got shifted up 2. And if I want to bring it down, I would subtract values and minus 2 or minus 5, and the graph would simply just shift downward. The asymptote would move with the vertical shift. Asymptote is determined by the plus 2, y equals 2. If it was minus 10, it would be y equals negative 10. Okay, there's other ways to change your y-intercept without changing the asymptote. And one of those ways that we can do that is by taking a function and multiplying it by a coefficient, such as 4 times 3 to the x power. Now, in this function, I'll use my same values for x, but then I'll multiply them by 4. So, again, with the xy chart, negative 2, negative 1, 0, 1, and 2. 3 to the negative 2 is 1 over 3 squared. That's 1 over 9. 4 times 1 over 9 is 4/9. Okay, so remember, 4 times 1 over 9 equals 4/9. 3 to the negative 1 is 1 over 3 to the first power, which is 1 over 3. And 4 times 1 over 3 is 4/3. 3 to the 0 is 1. 4 times 1 is 4, changing my y-intercept. 3 to the first is 3. 4 times 3 is 12, so this is getting stretched at a quicker rate. And 3 squared is 2. 3 squared is, 9. And 9 times 4 is 36. So, as you can see, in this graph, my y-intercept went to 0, 4, but my values, 4/9, 4/3, if I go from 4/9 to 3 to the negative 3rd power, that's 1 over 27, which is going to give me 4 over 27, increasingly closer to 0. Eventually, I'm going to be in the same situation where it's increasingly closer to 0, but in this direction, at 1, I'm going to be up at 12, so that's 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see it's going to get stretched. So it's kind of like almost someone took it and tugged along that y-intercept to bring it up to 4, and then each of the other values are also vertically stretched. So this 4 coefficient is a vertical stretch of the graph, but the asymptote remains y equals 0, which means our range of the function also remains y greater than 0. Okay, so that's kind of the basics of graphing. We're going to be getting into more graphing as we go along through the unit and evaluating exponential functions. And bring your questions into class tomorrow, and I'll see you there. Bye.